Okay, good evening, everyone. I'm really impressed of this HP mission critical system, and probably the session that I'm going to present you is kind of next steps after we use this kind of hardware. We should configure our databases properly and our SQL Server in order to use the full capacity and full options of this new amazing hardware for our mission-critical databases. So thank you for inviting me. First of all, it's kind of really a pleasure to be here. I'm delighted to be here because I also lead SQL user group in Bulgaria. So it's really enjoyable to present in front of these people, in front of community, and in front of people that are eager to learn and to know something new, or a different point of view at least. So my name is Magi Naumova. I'm Bulgarian. I live in Sofia, and I'm a SQL Server architect and trainer, Microsoft Certified Master, and MVP of SQL Server. So now, today, I'm going to talk about top 10 things you shouldn't do with your database, mission critical or any other database at all. No, I should speak louder, okay? Yeah, okay. Thanks. Yeah, I will. Okay. So I was silent all the day during the flight, so now I have a chance to speak and to speak louder. Okay, why exactly those 10 things? Why 10? Why exactly worse things? So I'll explain you shortly. First of all, I love to enumerate 10 things because you can enumerate on your fingers and you can remember easily. Those are not all the worst things that you can do with your database, I believe. You can do a lot more. But, for example, to format a disk drive when your database resides, but I'm not going to speak about those things. I'm going to speak about things that harm the overall database performance and the things that are kind of hidden, that kind of you don't know about them probably, or you don't realize that they really harm the database performance. So they even can cause data loss and data corruption. And I realize that they really happen most often. Almost 90% of my performance tuning projects are connected to wrong database and SQL Server configuration, believe or not. And people really don't realize that this is a very important point just before going to production to set the database and SQL Server with right options and right configurations. So, how many of you are DBAs, actually? Great. And how many of you faced performance problem with SQL Server? Even no DBAs. Yeah. Let me tell you two things. You're not alone. So, yeah, you're not alone for sure. There are a lot of people, especially administering SQL Server and databases, who face performance problems and even corruption and data loss, and they don't realize actually that at least half of those problems are connected to specific options on SQL Server and database levels. And the second thing is, I'm not going to tell you tonight some tips, tricks, or something like that. I'm going to talk about conceptions. Conceptions that are very, very important And I'm going to describe you those conceptions in order for you alone to be able to perform right configuration at your own databases. Because there are no silver bullets there. There are no one thing that should be right on every case. There are different cases, there are different databases, there are different requirements, and there are different workloads. And that is the reason that you cannot just read some best practices in the field and just apply them to your case. So the important things that I'm going to do, and I'm doing on my SQL Server Master Academy trainings, is to tell people and to make people understand the conceptions in order to make them decide and to make them take the right solution for the specific environment. So I'm not going to talk about me a lot, so we can speak after that offline. I'm running my SQL Master Academy trainings in Bulgaria and abroad. And I'll be here in Sweden in May also speaking about enterprise optimization techniques and virtualization of SQL Server. So hopefully I'll see some of you in the next 2 months. So the things that are important for SQL Server database configurations, I group them into groups, especially. Something that is important to tell you here. Well, when we speak about mission-critical databases, it's important to realize that mission-critical is not only some number of nines. Or mission-critical is not only disaster recovery and high availability. Mission-critical is connected also with performance of your database and with acceptable and constant values of performance. It's not like my query is running kind of slow right now, or is not running at all, or it's timing out today and tomorrow is going well. It's kind of constant performance of your database and overall system. And that's why it's so important to make those settings on the database level, on the transaction log level, and to have a right maintenance of your database and to have a very good strategy for database corruption survival. Some examples of wrong practices that are grouped in those two groups are, for example, I had a case just 1 week before with a really mission-critical system on my customer. They are insurance company and they have peak workloads at the end of the year. So they have a cluster environment, high availability cluster, failover cluster, and they have hit all those 10 things that I'm going to tell you about. All those 10 things. So nothing was configured properly on this environment. So what happened? When they hit workload peaks, they just, the SQL Server just stopped working. And it was a huge bottleneck, and they decided to disassemble one of the nodes and put memory and CPU on the first node of the cluster in order to try to make it happen, to try to avoid bottlenecks and to capture the workload of the end of year. So hardware couldn't pick up. At least the hardware cannot overwrite something that is not configured well. So they couldn't resolve this issue. And beside that, they had no availability at all. So 1 month after that, they called me and said, you know, we realized that something is wrong here. And we lost the business. We lost a lot of customers in this campaign. And we are going to start right now in order to prepare the server and the configuration for the next end of year period. So we were starting, and after making proper configurations on the system without touching any SQL Server code, without touching any queries, any indexes, we achieved double increasing in performance, only as a result of configuration changes, nothing more. So that's why I'm going to talk to you right now about all those mistakes and all those wrong configurations that are important to know in order to avoid in your environment, at least to check if they are at right settings in your environment. So let's start with the database level configurations. First of all, that I hate so much is to leave a database with defaults. Default settings are harmful for your database in production environment. Which are those default settings? First of all, database placement. I'm not going to talk about this at all. So I don't expect that the database will be on this path, placed on this drive in the production environment. But I'm going to talk on the next two options. How many of you are administering the production database of 5 megabytes? Nobody. That's right, nobody. So this is not a production database at all. So when we are going to administer our database in production environment, it's not this size. So we have to have really to set up the database with the proper size in our environment. Database growth, well, it's the same actually. The database can grow by a step of 1 megabyte, but it will be harmful for your database performance. Because on every growth, it will be with small steps and the pages will be allocated, and this allocation is slowing your database because it's performing while you perform activities against the database. So it shouldn't be performed on intensive or peak hours or even on a daily basis. It should be managed well in order to avoid this during the production workloads. So those two settings are actually really harmful, and sometimes we really don't realize how much harmful is that. It leads to NTFS fragmentation of your database. Let me tell you that defragmenting the drive, you probably know very well, it's not something that you would like to do on a daily basis, or at least on your production environment. This fragmentation affects for sure your large scans on the database. Beside that, those growth events are really expensive because they are happening during the workload. So you probably say to your database, the transaction or the workload should wait until my database is growing, and after that it will continue, but okay, how much it costs to your users? So for sure, transaction and loading performance is affected, and if you don't control at all the database size, or the database, the drive can become full, and you will really have a problem at all. So let me explain some examples. First demo will be to show you how expensive it is to leave those default settings. So first, I'm going to set up an X event session in order to capture the file growth events. you know very well that on SQL Server 2012 we used extended events, and we have to use extended events actually because our suite profiler is kind of deprecated. So it's better for us to get used to extended events. They are really helpful. They are light. They don't harm your workload and your server performance unless you just capture everything you can do with them, but I'm sure that you will not do that. So let's create an extended event session. Sorry about that. And I'm going to capture the growth of file event. So how many of you work with extended events? Great. Okay, so we have a lot of extended events in SQL Server 2012, even more than in 2008 R2. So we have all those profiler events, almost all of them, as extended event, and we can capture, we can easily switch between profiler monitoring and extended event monitoring. The very good news in SQL Server 2012 is that extended events has a graphical interface. And because of that, we can easily set up the X event session, and we can easily monitor and watch data live during the workload. So how to search event? I can just use a word that I know about. For example, file growth or file size change. I have a database file size change. I have a data log file size change. I'm going to use this one and use everything by default and save the data in ring buffer or in memory. I'm not going to save it on a file target. You can save it, of course, in a file target. You can process the file target after that. And you can load the data in the table and analyze further, etc. But we don't need this at this moment. So I'm going to start the event session. Okay. So the next step is to use a trace flag in order to have errors registered inside the error log of SQL Server, and in order to monitor every initialization of file. So every auto grow by default, if you don't configure instant file initialization, is going to create and initialize zeroing, perform zeroing on our database file and transaction log file, of course. So I'm going to catch those events, and I'm going to cycle the log in order to find out easy what are the events. So create a database with default settings, you see, set the recovery model to full, and perform a full backup in order to activate actually and work in the full recovery model. I'm going to clear the wait statistics in order to get, after the test, the asynchronous IO completion wait, which wait is generated during the event of database increase. So you see how many and what is the duration of asynchronous IO completion event. Okay, so let's create a table inside the database and perform a data loading. This is absolutely terrible data loading code, but I'm not going to optimize the code here. It's a code that I used to see that a lot of times. So let's watch the events. Watch leave data. And you see, this is the number of events. These are the events that are happening during the load of the data. And these events, it's changing the file size, either transaction log or database or data file size. So they are increasing a lot because I have 1 megabyte data file growth by default. Okay, so it's still executing. I even don't have 1 million of rows here. Of course, my laptop is not so performant. My disks are regular laptop disk. But anyway, it's just they are not so much rows actually. So this is still happening. You see, they are huge. They're really huge. And it's still executing. Okay. So after a while, hopefully not a while, not so long, we will see that it will complete. So nothing else is working on my laptop right now. It's just this one, okay? It's terrible. So let's see why is that. Okay, so we have those events as a number of data file and transaction log file growth. You see, here we have a specific data file or transaction log file event. So we, of course, can group, can filter those events, can work, can export, or whatever can do here with extended events, but it's not the point of my presentation right now to work with extended events, just to show you that this is happening. And this is happening, you even don't realize that this is happening behind the scene. So what's next? Let's see what is the asynchronous IO completion. Well, it's about this is the wait time that I have. This was about the duration of the operation here, and let's read the log. Okay. You see, I have zeroing the log, which is going to be constantly zeroing, so zeroing the data file, etc. So everything is happening during your workload. Zeroing means initializing, editing the allocation pages, and preparing those data pages for writing after that. So let's see if I use instant file initialization. How many of you use instant file initialization? Great. So for those that do not use instant file initialization, please do. Please do. It's very important to you because it saves time during growth operations, during recovery, for example, of the database, during creating of the database, during TempDB and restarting of SQL Server, for example, then initializing the TempDB. So this is a very important setting. This setting allows SQL Server to bypass zeroing phase and to very fast perform growth and initialize allocating operations without this zeroing operation. Well, it's not on by default because of slight security risk. If you go and use DBCC page and explore the data page through DBCC page, if the page is not zero initialized, you can see the old data in the disk that was saved in the disk. So this is the slight security risk, but I believe that this is not something that is the huge reason of not using instant file initialization. So at least I don't, I haven't have a case when this security risk is really important, so important to consider not using instant file initialization. So how to enable instant file initialization is a local security policy for SQL Server account. And if your SQL Server account is a domain user or local user account, for example. If it's a system account, it's enabled by default, but you have to be careful with using system accounts, okay? So, user right assignment, perform volume maintenance tasks. So, I need to add SQL Server account here in order to have these settings enabled. I'm going to do that. Okay. This is the account of my SQL Server Denali. So you probably realize that I have to restart this SQL Server in order those security settings to take effect. Sure I want. And we'll see now if we bypass the instant file, if we bypass zeroing. Yeah, sure. Can we achieve something as a performance benefit with this test? Okay. This is because I have restarted SQL Server, so I have to switch on those trace flag again. And let's check our session. Okay. Yeah, it's not running, of course. Start. Okay, let's check now. I'm going to create the same test. Absolutely the same test, but the database is with different name. Okay, and asynchronous IO completion wait, creating a table, and loading the data. Okay. So now, what is the difference here? Well, I expect the same number of events, but the difference is that those events, at least half of them, will perform faster because there will be no zeroing of the file. Well, is this a problem resolution? Not at all. It's just like saying, well, my laptop is restarting faster and it resolves my problem of hanging. Okay, this is not a problem, the resolution of the problem. It's just kind of optimization here. You have to do that, at least. You have to enable instant file initialization because it's very important, at least for mission critical databases, at least when you need to perform a fast database recovery or to optimize the process of database restore. And this is very important to know, but the optimization, here we go, we have 89 seconds, just to compare with the first test. Okay, so let's see what kind of I/O completion events do we have. A lot. Wait time in milliseconds is great, is a large, even more. And let's check the lock. Well, the good news is that we have a zero wink only on transaction log file, not the database file. So this is about, this saves us, you see, about 40 seconds, which is great, actually. So this is the first step that we have to do to enable instant file initialization on our machines. So let's perform a final test here, and let's create. We have approximately the same number of events here, and let's create a database and set the settings. Well, this is the settings from the database that dbconfig test1. So I just copy the size of the database and the size of the transaction log. And I create this database with predefined database size and predefined transaction log size. Well, it takes some time, of course, but I don't expect this time to be during the production environment, during the workload time. You can probably define a job, which is a common practice, at least I use this a lot of times, to create a job to increase the database file, for example, once a month, or whatever that, depending on your case. In order to reduce those weights. So asynchronous IO again. I'm creating a table and loading the data. Here we go. Well, the last test was 81 seconds, remember. Yeah, that's what I'm talking about. It's 9 seconds. 9 seconds. And we have really those records in the table. So let's check asynchronous IO completion. 0. 0. So we don't have asynchronous IO waits because we don't have growth events. We don't wait for growth events. We have the same number of events. Nothing new as an event is registered here. So we don't have any new zero-wink events inside the log. So all the time it takes to load my data is 9 seconds. Not 91, neither 123. Okay. So just configure your database properly and you will save a lot of time during the workload. Okay, what are my recommendations here? Actually, I said that I'm not going to tell you best practices nor silver bullets, nothing. Just I'm trying to explain you the facts and to push you to configure those settings. First of all, of course, isolate database and log file. Manually manage file sizes. What does it mean? Monitor auto-grow settings for a limited period of time. So you have to know your patterns in order to define the proper size of your database and the database files. And take care to manually grow those files. Of course, enable auto-grow just in case, but take proper action to avoid growing of the file during the workloads. Turn on the instant file initialization. It's not on by default. It's not only on Enterprise Edition. It's in Standard Edition also available. So it's something that should be configured on every production system. What about other options? Well, some auto options are also tend to be misconfigured. One of them, thanks God, they removed the option auto close in 2012, but it's a harmful option also. Auto close sounds good. Well, of course it sounds good because it kind of saving your resources when the database is not used, but it's not true. It's not true at all. It's even more expensive to close the database, to remove all those objects in the memory, and to load them again after a while, probably after a few seconds, for example. If your database comes from SQL Server Express Edition, this option could be on by default. On SQL Server before 2012, just check. This option can just hang your database and just can leave your database in recovery state even. So this is very dangerous actually. Auto shrink option as option on database, as database option, is something that I hope and I really expect to be the next one that will be removed in the next version, because it's just a terrible option. I will show you what the shrink means and what is the shrink doing on the database, inside the database, on the second part of my session. So then I'll go to talk about shrinking a database. At this point, just remember to never use this option. Never, ever. So what about statistics? Well, just leave those as true. Auto-create and auto-update statistics is a good practice to manage statistics, to leave SQL Server to manage statistics automatically, and to add statistics maintenance in your maintenance plan. Why is that? Well, it's because for some tables, for example, for large tables, or for tables with ascending keys, with ever-increasing keys, you can end up with performance problems and query timeouts due to two things. First of all, due to reaching the threshold of updating statistics because of loading so much data. And the second is to query to perform badly because of old statistics. So for those cases, you have to manually and additionally maintain statistics with some jobs, for example. And this is part of your correct maintenance plan, to take care about your statistics. There are trace flags that take care about large tables and manage statistics on large tables. They just mark ever-increasing columns and your auto-increment clustering keys, for example, as increasing columns and perform frequently updating statistics on those columns. This is set by trace flag on SQL Server level. And there is a trace flag for large tables, to manage statistics on large tables, and the trace flag says that for large tables for about 10,000 of rows, for example, or million of rows or several million of rows, the threshold is not just 20% of updates on the table or on the column, but less, even 3%, for example, of updates. When updates hit those 3%, for example, the statistics will be auto-updated. So, but at least you have to start from here. And start from here means switch on, create, and update statistics. What about synchronous and asynchronous update stats? When I was talking about performance on mission-critical system, well, if you update statistics synchronously on database level, then you risk for some queries to time out because reaching a statistics update threshold. Statistics are updated during the query compilation. So your query could wait from time to time for a statistics update to pass. In order to avoid that, just turn asynchronous update statistics on your database, which means that the statistics will be updated lately after, for example, a couple of seconds in the background, but will not stop your query from executing. And of course, you should test this option, at least, before implementing it. But almost on all environments, this option is performing very well. What about transaction lock, configuration, and support? Well, usual complaints for transaction log behavior is connected to transaction log behavior are probably some of them you heard about. I tried to delete the log file. It was locked, but I finally managed. So I finally found a way. That was my favor. I don't know why backups are taking so long, or why the transaction log is full and how to manage that. Everything is connected to improper management or improper configuration of the transaction log file. Which are the wrong practices of transaction log configuration? Again, leaving default size in placement. Default size of the transaction log is 2 megabytes and 10% file growth, which is the same effect as the database file. Well, this is even more important because the transaction log is very critical for your database. And beside that, transaction log is always zero initialized. It cannot be optimized with instance file initialization. It's just the way it works prevents the optimization of instant file initializations. It's always zeroing. So it's even more critical your transaction log to have proper configuration. Of course, a lot of options, a lot of actions, wrong actions are taken in shrinking, truncating, or clearing the log. And why is that so important? Because if we don't manage the transaction log properly, we could end up with transaction log running out of space, inability to recover from backups, or performance problems connected to log fragmentation and log file growth. So I'm sure every one of you know how transaction log works. I'm just going to tell you some important things in order to show you the demo afterwards. So the transaction log contains of a series of smaller files inside of it. They called virtual log files. So VLF are active and inactive. So active VLF is a block inside a transaction log where we have an active open transaction. That's why it's active VLF. We couldn't do anything with active VLF. We could not clear the active VLF. We could not shrink the transaction log with active VLFs, full of active VLFs. So active VLF is something that is untouchable. Okay? Inactive VLF is a block where we don't have any open transactions, or they have been checkpointed, and the inactive portion of the log can be reused. Backup first and reused after that. So when activity moves throughout the transaction log files, inactive VLFs become active VLFs. When we reach end of the file, then it depends if we have inactive VLFs available for reuse at the beginning of the transaction log file. If we have those, then our transaction log files and VLF at the beginning of the file, the transaction log can be reused. So they become active. And the parity of the VLF is flipped. So the VLF file is cycling. And it is cycling only when we have inactive available VLF for reuse. And that's important point here. So what is the process that makes a VLF inactive and mark the VLF for reuse? It's a backup lock. It's so simple, actually. When you are in full recovery model, only the backup lock statement marks inactive VLF file for reuse. If we don't have a backup lock, we couldn't have inactive file VLF for reuse. Then, when our transaction continues, then the transaction log file has to grow. And transaction log file is growing because there is no VLF at the beginning of the file to be reused. And that's the main point. So, what's behind this point actually? So we have an active portion of the log and we have inactive portion of the log. So when we perform a backup here, our log file, which is a red line, is a physical size, physical file size. So our physical file size remains at the same size because we have a VLFs that can be reused. So we have a large inactive portion of the file with VLFs inside that can be reused. And this is the main point. So our main goal is to configure the transaction log file in such a way that we don't have so much VLFs inside and we don't allow the transaction log to grow a lot as a physical file. So we need to perform a regular backup of the log in order to achieve that. Excessive file autogrowth actually causes a lot of VLFs to be added. For example, here, this is an autogrow of the file, transaction log file with the small steps. And those VLFs are added during this growth, and this can negatively affect performance of the log and slow down the whole transactions. So it's synchronous, of course, because you know the process of hardening the lock during the transaction. So if there is no place enough in the transaction lock, not only for the transaction, but for compensation records in order to transaction lock to be rolled back if needed. So if there is no such place enough, then the transaction lock should grow during the transaction and zeroing and initializing. What are the VLF creation rules? So this is actually important according to transaction lock configuration. There is no best practice for initial size, configuration of transaction lock initial size. Why? Because it depends on a lot of things. Your workload, your transaction processing, your, for example, if you have replication, transactional replication or mirroring or something like that. So I couldn't say just make the transaction log file 30% of your database. It can be set in that way. You have to perform monitoring, for example, during a month or during a week, in order to see how much the transaction log is growing and to set up the size of the log properly. So what does it mean and how much VLFs are created during the log growth? So for specific file chunks, these are the number of VLFs that are created. For example, when file chunk is 64 megabytes, then SQL Server creates 4 VLF per chunk, per file chunk. Okay. Here is the example. If the transaction log needs to grow from its default size of 1 megabyte to 1 gigabyte, then with 1 megabyte default steps, it needs about 1,024 steps, 4 VLFs each, which is this number of VLFs inside. This means the transaction log is highly fragmented. Why is fragmented? Well, the threshold of transaction log fragmentation is 100 VLFs. So we should keep the transaction log VLFs to up to 100. So with proper configuration, with these steps, for example, which is kind of maximum steps of recommendation, we need to 2 steps of 8 VLFs each and 16 VLFs at the end. So this is a transaction log that is not fragmented and is configured properly, and this is the wrong configuration, which is default configuration. And the last demo, should I run the last demo or should we have a break? Okay, let's have a break then.